All right, so we're going to add and subtract rational expressions using a common denominator. This is just the common arithmetic you usually learn in elementary or middle school. And what I'm going to do is I'm going to compare that with what you're doing now. Like if you had, say, two rational expressions and you wanted to add or subtract these things. Then we would need to find some expression in the bottom that's the same, right? We need the same denominator in order to add anything. I'm going to explain that with what we already know here in this module. And in the next video, we're going to do these, but I'm going to do a small comparison before we continue onto that at the end of this video. Okay, so why do we need the same denominator to add or subtract fractions? What's going on here visually? So real quickly, this is the situation that we have. Let's say that you've got half of a pie, right? You've got half of a pie left right here, and you've got a third of a pie. We can't add these together because there really are just different quantities. It wouldn't make sense to add 1/2 to 1/3 the way it stands here. So what do we need to do? Well, we need to split them, the entire thing, both the entire, like all of the compartments, the total compartments, both filled and empty. That's going to be your total. That's what that 2 means right here. We need to split all of the compartments up equivalently in such a way that the same thing over here, we have the same total compartments. That's the only way we're going to add the total compartments together. If you have two differently numbered compartments, or size, if you will, respectfully, then you need to rationalize this to where you can actually add those pieces together. Not only that, you haven't just split the entire compartments, you've also split the shaded portions, what was left. So let me show that. So if I split this one, first thing we need to do, just arithmetically, is that we need to find some sort of denominator that's the same in both of these. So it's going to really be your least common factor, least common multiple. I'm going to guess 2 times 3. That's all we really have here. It's quite simple. So the compartments I need total in both of these is going to be 6. Those are the total compartments each one of these. So in order to get that, I need to split this one by 3, both the total. So I do that here in the math. So let's go ahead and split this one by 3, both the total, but we also need to split the numerator, like how much is shaded. So that's why we do this. We have to multiply top and bottom to make this make sense over here mathematically. So that's exactly what I'm going to do. In order to split this into 3s, I'm just going to do something like this. Let's see here. And now we can see that the total compartments are now 6. You've got 1, 2, 3, 4, 5, 6. Let's give it a better visual here. So then now we can see that we've got, what is that? That's going to give me 3 out of 6 that are shaded here. 1, 2, 3 out of 6. And then we do the same thing over here where we split this into 2, each one of these into 2 proportions so that we can get that 6 for our total compartments in order to add what's left over in our pies here. So then if I look over here and I split this each by 2, I'm going to have 2 out of 6 shaded. So I think now that y'all have a visual as to what's going on, as to why we do this magic over here with the math, why we're multiplying this thing on top and bottom in order to get that 6. We're not just following the rules, which we are, of course, where we're multiplying this, you have to do it to this as well. And a lot of people argue, well, that has to be unity, but I think the visual makes a whole lot more sense for us. So if we add these together, we're going to have 5 over 6. We had found our least common factor being 6, and I explained why that was. Now we have rationalized these to where we can add them both because they have the same total compartments. So where does this make sense, or how does this make sense in terms of rational expressions? Well, and there's really no connection between me adding the x here. I don't want you to think that. I'm just picking some random example. I'm just using the same numbers, kind of just tacking on it, or giving it a rational expression respectfully. So we can see out of these, let's see here. that they do not have the same common denominator. So that's quite clear. So what I'm going to do here for us is kind of explain with the same method what it is that we're trying to do. Now this is going to be in the next video, and I'm going to explain what we need to do here in comparison, right, to what we just did in the next video. So again, same total compartments. We need something of this nature, and I'll explain that in the next video.
Come in! Let me in! Come in! Come on! Kill me! I'm here! I'm going down! Come in! Ninja vanish!